Tom Marsalo, Eric Dillon, I will let you guys take it away. Thank you very much.
Great, thank you, James. Good afternoon, everybody. Everybody hear me okay? Thumbs up if you can. James, you got me? You can hear me okay?
Yep. We got you.
We got you good, Tom.
All right, well, thanks for joining us this afternoon. As James mentioned, my name's Tom Marsala. I'm the Director of Sales for JB Industries. I kind of cover the west part of the country from Colorado through to Hawaii. So the Orion Group falls firmly in the middle of that patch. And yeah, it's a pleasure to be here today. What we're going to do today is talk a little bit about A2L fundamentals. I mean, I'm sure that you guys have heard all of this before, multiple times. I know the refrigerant guys, Chemours, Honeywell, they've all been out there actually talking about it. So I'm sure that you'll all have a pretty good handle on A2L and what it means for you. But I'm just going to recap some of the main areas, and then we'll talk a little bit about some of the myths around A2L, which you may or may not know about, the truths and falses. Talk a little bit about the A2L tools, particularly from a JB perspective, and what you need to consider when you're using tools with A2L refrigerants. And then we'll finish off with just a brief overview of some of the best practices that are coming out of AHR and other organizations out of there. So yeah, look, feel free to ask questions as we go along, but you know, again, if you want to leave them until the end, that might make it a little bit more efficient, and we can get you on your way and getting out there and making money, which you should be doing on a hot day in Fresno, right? So okay, so a little bit of review of A2L. And so a little bit on the actual timeline of refrigerants, and I'm sure most of you are aware of this, but you know, if we go back to the 1930s, we had R12, and R12 was a great refrigerant. It was efficient, but they discovered that it was making a massive hole in the ozone layer. It had a really high ozone depletion potential. And, you know, somebody who grew up and lived in Australia for many, many years in Brisbane, which is right underneath that ozone hole that was there, I can 100% attest to the fact that there definitely was a hole in the ozone layer, because 10 minutes out in the sun for us, then you're literally toast. And so if you see a lot of Australian TV programs, you've got the kids running around in their floppy hats, and you know, we're doing skin cancer checks every month, basically, when you're living on the west coast, on the east coast of Australia. So yeah, there was definitely a hole. So it wasn't politics. There was definitely a good reason to change that R12 out, you know, to R22 in the 50s, and you know, R22 had a medium ozone depletion potential, and they thought that was going to do the trick, but it didn't. That hole just kept getting bigger. You know, eventually that prompted the change to R410A, and R410A has basically got a zero ozone depletion potential, and that kind of fixed it up. I mean, that hole has closed. It's still a little bit thin there in Australia, so you still get burnt, but it's definitely not as bad as it was 20, 30 years ago. So, you know, there have been improvements. So if we move now to the 2020s, right, and we fixed the one problem with the ozone depletion, and, you know, created another can of worms, because nobody was looking at global warming, nobody was looking at greenhouse gas emissions, and yeah, they discovered that R410A, unfortunately, it was great, zero ODP, but had a pretty high global warming potential. And that's really where we start moving into the whole A2L side of things. R32 and 454B were both introduced in the 20s. And actually, R32 is a component of R454B. It's been around for a long time, and they've been using it in Europe for many, many years. So it's not new globally, but certainly has been new to the US market.
Hey, Tom, just real quick, 32 is new to the US market as a single component refrigerant.
Yeah.
It is actually used in 410A is 50% R32 as well.
Correct. Yeah. And is it 150? The blend? 130, 134, 134. I've got a chart on it a little bit later on, what the actual blend is, right?
Okay.
All right. So why A2L refrigerants, right? So we've been through that. There's the Montreal Protocol in '87. You know, that was phasing out of CFCs. They were replaced by HFCs. Again, we spoke about the zero ozone depletion. We spoke about the fact that they had high global warming potential. So in 2016, there was an amendment to that original protocol, which then called for the reduction of HFCs. And that's why we've seen 410A moving to those new A2L refrigerant classes. So what is an A2L exactly? So, AHR classifies refrigerants into, really four classes, but they've got an A and B component. So A being a low toxicity and B being a high toxicity refrigerant. A2Ls kind of sit right in the middle between A1s, which is your 410As and all the current refrigerants you do have, and A2s, which are flammable. And the L stands for mildly flammable at the end of the day. They're all pretty low global warming potential, but you'll see that there are some that are lower than others. And I suspect that a lot of the manufacturers out there have decided to go R454B for various reasons, whether it's the fact that it's got similar pressures to 410A and it's going to be an easier transition over. But I also think they've also looked at what the GWP of R32 is, and it's very close to the 700 threshold that is mandated. And I suspect they're going to tighten it up as the years go by, and we're going to see R32 being there's going to be pressure on R32 to be transitioned out, and potentially R454B as well. As we get as the years go by, and we get more and more issues with global warming. So, I mean, the industry. This industry used to be an industry that didn't change much, but I think we're going to see a lot of changes a lot faster over the coming years. All right, so how's it going to affect the average tech out on the street, right? So I mentioned we've got two main A2L refrigerants that have been adopted by the equipment manufacturers, at least for the comfort HVAC market, so residential, light commercial, etc. R32 by Daikin predominantly, and it's actually Daikin proprietary refrigerant, and R454B by Carrier and almost everybody else out there. Daikin mini split systems have already started shipping, so we've seen some of those out on the market at the moment. So A2Ls are out there, and Carrier are saying that they're going to start shipping their equipment in Q3, which is a couple of months' time. So I think realistically, the average guy out on the street is going to start seeing this stuff sometime in 2025 for new installs, and then service somewhere thereafter. So no need to panic quite yet, but I mean, you've got to be prepared and understand what it actually means to you from a tool and equipment installation best practices standpoint. Oh, sorry. So here's a slide I was mentioning earlier on, which just gives you a bit of a breakdown of those three different refrigerants. 410A, which is a class A1 refrigerant. As we mentioned, it's a blend of 32 and 125. You can see the GWP is 2088, really high. And you can see on the other end of the spectrum, we got an R454B, which is an HFC HFO blend, so R32 and 1234YF, which is predominantly used in automotive at the moment. And that's got a GWP of 466, which is kind of well under that 700 threshold. And you see 32 is sitting at 675. So, I mean, it's pretty close there, and there's not much margin for error, or not much buffer. They're all those two refrigerants are pretty much the same in terms of their flammability. And by flammability, we normally talk about the propagation of the flame, compared to the kind of reference it to propane being highly something that really propagates, the flame propagates. And these are mildly flammable. When I say mildly flammable, I mean mildly flammable. I've heard some refrigerant manufacturers actually compare it to olive oil in how it's in the flammability of actual R32 or 454B. I think that's kind of understating it a little bit, but yeah, that's kind of what we're talking about. No other changes with the POE oils, and the charge sizes are slightly smaller than 410A, and 454B. In the case of 454B, the pressures are pretty similar to 410A, so that transition shouldn't be too much of a problem if you can take the flammability side out of it. So there are other A2Ls out there, as we mentioned earlier on. So if you look at air conditioning and comfort cooling, those two main refrigerants, 32 and 454B, are the ones that the majority of techs will come across. But if you start going up into commercial and industrial refrigeration, you'll see that there's a whole bunch of others out there as well. 454C and 454A, and the 1234s as well, and they've got very low global warming potential. The difference between those and a 454B, for example, is that there's very small glide in 454B, so it's very easy to top the systems up. But as you get down into those lower GWPs, the glide in the refrigerant actually increases, and it just takes a little bit more effort to manage those refrigerants inside those systems. All right, so we're going to just try and dispel some of the myths around A2L, and there's a lot of panic out there in the industry. I'm going to blow myself up, and I suppose the first one that everybody talks about is, hey, A2Ls contain propane that can cause a fire, which is absolute rubbish. I mean, there's no propane in A2L at all. You saw that chart earlier on, which actually gives you the refrigerant blend inside there. There is no hydrocarbon inside an A2L. We talked about the flammability, and equivalent to olive oil. It takes 1,000 times more energy to ignite propane, to ignite an A2L, than it does to ignite propane, and that's massive, right? I mean, you've got to have a very high concentration of refrigerant, and you've got to have a very hot naked flame on that to actually just ignite it. Never mind the fact that you've got a very low flame propagation, and that's going to burn slowly, and it's probably going to self-extinguish itself before it gets anywhere. So that is one of the major myths out there, and that is what one of the major things that most techs are actually worried about is the flammability of the actual refrigerant. And so then you ask yourself, why do I have to change anything, right? If it's not really flammable, what's all the fuss about? Well, this is all going to, as usual, it's all going to come down to manufacturer equipment warranty, liability, and you know as well as I do that there's plenty of cowboys out there who are going to do stuff, and somebody's going to do something, and it's going to reflect on the entire industry. So when bodies like AHR and others actually bring out those guidelines of safety mandates, safety guidelines, they're doing it for a reason. It's really to protect the industry rather than because something might happen. So yeah, so if you're thinking I can get away with some of my old tools, you probably can, and we'll talk about that a little bit later, but it wouldn't be my recommendation. It's probably just safe all around, just to kind of go with the flow.
Yeah, real quick, Tom. One of the things I like to tell folks is, this when you get down to it, the new A2Ls, they're slightly, moderately, however they want to define it. They're not propane. They're not fuel, right? They are, however, slightly more flammable than what we're used to.
Yeah.
Right. And so that's where we want to, just do things, do our due diligence to do our processes and our tooling and everything, and get it in line with what the recommendations and requirements are for this stuff, just so that we stay safe and our customers stay safe.
Yeah, exactly. All right, so look, one of the other things that people are asking, do I need an additional certification to handle A2L? Well, technically not if you hold a 608, right? But I know that the EPA is looking at new guidelines for certification. And Eric, you've probably got more information on this than I have. But I know Section 608 holders are going to be grandfathered in. But there's new stuff coming, right?
Yeah, the Section 608 covered ozone depletion. It does not cover the greenhouse gas effects that we're going through, and it doesn't. So it doesn't. There's no criteria for it in 608 as far as the A2Ls. But the EPA is running under authorization under the AIM Act, and the AIM Act actually mandates the EPA to get in place some type of training and or certification program. So yeah, I think pretty much industry wide we expect that there's going to be an additional license required for this. We're hearing rumors that we may get that decision this month. Prior to that, I was told we were probably not going to get it till September. But it is 95% possibility that we're going to need an additional license for this. We just, the EPA has kind of, this stuff is changing, and they've come out with some decisions when we didn't expect them to, and they've come out with additional decisions like allowing for sell-through on equipment. So yeah, everybody's just kind of spinning, waiting to hear.
All right, yeah. So I probably need to update this slide at some point, but for the moment, it's probably accurate. So
for the moment,
yeah.
for the moment, we are covered under our 608.
Right, great, perfect. All right, so the other one that people are talking about is that, hey, we can retrofit A2L, right? So if we've got equipment out there, we can just throw A2L refrigerant in there. So they are definitely 100% not compatible with equipment that's designed for A1. So you can't take an A2L refrigerant and put it in a 401 system or any other system out there. It's just not compatible at all. They do use different compressors, the A2L equipment. Some of the electrical components changes, depending on the charge side. You have a refrigerant detection system within the equipment side of things, expansion valves, TXVs, etc. So you definitely cannot do that. That's a no-no.
Yeah, all pieces and components have to be UL listed for use with A2Ls.
Yeah.
So anything that was using an A1 refrigerant is not going to be UL listed for use with an A2L. So it's we just can't do it.
Right, can we use an existing recovery cylinder for A2Ls? And that's, again, definitely not. So the new cylinders will be gray. They'll have a red stripe around the top. They'll be equipped with a relief valve and not a rupture disc. So the relief valve is almost like, automatic, like a pressure release. And most importantly, they're going to have a left-hand thread. And you are going to require an adapter of some sort to take refrigerant out or get it back into that refrigerant tank. An adapter or a hose with a left-handed thread on the end of it. And you see that actually with some of the other refrigerants on the market as well, some of the other flammable refrigerants. So it's not new, but certainly new for most of the people out there in the field. Right, the big one, at least from JB's perspective, right? I need to change all my tools to handle A2L, right? Well, that's not true either, right? Absolutely not. You've got the marketing departments of all the major tool manufacturers out there going absolutely crazy and putting A2L on everything. If it's a brass fitting, there's got an A2L stamp. It's ridiculous. It's absolutely ridiculous. But the issue is, if you don't put an A2L stamp on it, then you keep getting questions: is this A2L compatible? Oh, I'm not going to buy that. It's not A2L compatible. So it's an overkill. Absolutely, I 100% agree. But really, there's only 4 tool classes that you have to look at. One is pumps. The other one is recovery machines. Obviously, your gauges, because you've got different PT charts, and probably leak detection. Those are your pretty much the tool categories that you really want to be evaluating within your current setup. And it's really, as it says here, only tools that touch the refrigerant circuit. They're the ones that need to be A2L compatible. Right, I can no longer sell or install R410A equipment, and you know, you mentioned earlier, Eric, they keep changing this, and they have done over the past couple of months. But I think it's pretty much cast in stone at the moment. Now is, you know, no 410A systems available for sale after January 1, 2025. You can still continue to install equipment that you have bought until the end of 2025. 410A components will be fine. I mean, pretty much they'll be available indefinitely, because it's not a phase out of 410A, it's a phase down of 410A. So 410A will be around for a long time, but just at a much lower level. And anything that's self-contained with 410A in it can be installed until the end of 2027. I think that's the latest, unless you got any other information, Eric. But I think that's the latest information that I've got on that.
Yeah, on the top bullet point there, you know, the way it's breaking down right now is they can no longer manufacture 410A after January 1st. They have extended sell-through dates. So we're going to have at least another year for instance, for like Johnstone's to sell that product that we may have in inventory. They just can't manufacture, and we can't receive it after January 1st.
Yeah, no, you're right. So guys, if they've got it in their inventory, they're okay to sell it until for a further 12 months.
But the thing I would say is don't count on that, because most of the manufacturers are either switching over or soon to switch over to the new A2Ls. So the 410A equipment is going to dry up, I think, pretty quickly. So I don't think we're going to have a huge inventory surplus of it.
Yeah. Yeah, so I mean, you know, that goes back to what I said right at the beginning of this presentation. I mean, for the average tech out there, you're really only going to start seeing A2Ls in the market in next year. You know, unless you're dealing with R32 mini splits at the moment. But you know, for anything 454B related, I think the majority of people, unless you're like, you know, on the bleeding edge of things, and you're right there when the new stuff's coming out next quarter, most guys are going to see it during the course of 2025.
Yeah.
So we spoke a little bit about this earlier on about topping off systems, right? So and that comes down to the refrigerant glide. So you got no issue with R32. You can top off the system. There's no problem. 454B is the same, very small glide. So you don't have to recover the entire refrigerant charge. You can do a normal top up as you can today. I'm not so sure about A and C. When they start making themselves present, they do have a much higher glide. So I think that's going to be down to the manufacturer, and it's not something I have information on at the moment. And you're not seeing that stuff in the market yet. But you know, if you are on the refrigeration, on the commercial and the industrial side, you know, that's just something you're going to have to consult your manufacturer about. Line sets, another one that people are talking about. Hey, you know, am I going to have to change out my line sets? No. I mean, you could, you know, as long as the line sets are correctly sized and they're pressure tested and they're properly flushed and cleaned and purged, you can use existing line sets. And, you know, that's, I suppose that's a major thing for most people out there. All righty. So those are just, you know, I just kind of put together some of the most common you know, common questions that have been out there, and there's a bunch more, but you see most of them can be answered with common sense at the end of the day. Yeah, so it's not rocket science, definitely not. All right, so a little bit about the tools, right? So I mentioned earlier on, you know, 4 main categories, you know, manifolds, gauges, not manifolds so much. I mean the gauge part of the manifold, pumps, recovery machines, and leak detection. So, you know, what does A2L compliance mean? Now, you got all these little stickers out there: A2L certified, A2L compliant, A2L capable, A2L compatible, right? What do they mean, right? They don't mean anything. There is no body for A2L certification of tools at the moment. There is, you can send an item of equipment to UL for ignition testing, but it's an ignition test. It's got nothing to do with A2L. It's a standard ignition test. So, for example, JB manufactures a recovery machine, the F6 Boost, and that has been tested by UL to A2 for A2Ls and A3, but from an ignition perspective, right? It's not a specific A2L test. So anybody out there who's telling you, I am A2L certified, you've got to ask them the question, who are you certified by? Because there is no certification body. Ultimately, all the manufacturers out there are self-certifying. I mean, that's what we're doing at JB. There are guidelines that are available. They talk about, brushless DC motors so that you're not causing an arc in any way or a spark. A locking power cord so that you can't pull the power cord out by mistake and you get a spark between the power cord and your AC input. The switches are soft touch, which means that there isn't a gap in the switch itself where you can actually have an arc and produce a spark. Those are all the basic guidelines. So if you're meeting those guidelines, most manufacturers out there are self-certifying. We're taking the approach that for something like recovery, which is the most important one because you are actually touching the refrigerant, we've gone one step further and we've gone. We are certified with UL for ignition, and we can go all the way up and recover propane. But yeah, on the pumps and all the rest of it, it's a self-certification process. And if we talk about pumps, and this is an interesting one, everybody's saying, well, why do I have to change my pump? Yeah, I mean, it's a good question, right? Basically, when you are evacuating a system, there shouldn't be any refrigerant in it anyway, right? So why would you need an A2L pump? I mean, it makes no sense. And that goes back to what I was saying right at the beginning about liability and about somebody's going to do something, right? Somebody's going to evacuate a system which has got no refrigerant on it, but, he's got 4 tanks of propane right around the corner, a couple of feet away, and something's going to blow up and there's going to be a liability issue. So, and it'll come down to warranties with the equipment manufacturers as well. So you go back to a guy here's a warranty claim, and the first thing they're going to go through is a little bit of a checklist with you, right? Did you follow these standard procedures? Did you use A2L compatible or A2L certified tools? And those are standard things that people ask when they're trying to wiggle out of a warranty claim. So I think it's just going to be good practice for technicians out there to actually try and make sure that their tools are compatible with the new refrigerants, even though compatibility doesn't really mean anything. It's just going to save you potential grief in the long run for probably a small financial outlay to start with, right? So yeah, that's my 5 cents. I'm an engineer by trade. I'm a sales guy now, so I look at what they're saying, particularly about vacuum pumps, and I'm going, why? But I understand the other side of things as well. So if you're out there and you're using your old AC pump on an install, it's going to do the job, right? There's no refrigerant around, but yeah, you may run into other problems that are not ignition related, which potentially might cause you more issues in the long run. All right, so the required tools, and we've touched on this. So, your analog gauges, obviously, they're going to need to reflect the new PT charts for the new refrigerants. And if you're using digital, you need to check that you're supporting all the new refrigerants. Most of the digital manifolds out there have all got 32 and 454B in them. Not so much 454A and C. Some of those have yet to be updated, but you'll see most of the manufacturers will be updating those remotely over the air the way they do. No change in hoses, even though you're going to see people out there saying, oh, you need an A2L, a special A2L hose that's branded A2L. That's just marketing. The rubber's the same. The brass is the same. The only thing that's going to change potentially is the left-handed thread, but on your standard hoses, I wouldn't bother. I'd just use an adapter. It seems a bit, it doesn't make sense to actually have a hose with an A2L fitting on one side because you can only use it for one thing then. And even though we at JB sell those hoses, I would just recommend you just go out and buy an adapter. a lot of guys, a lot of organizations out there are actually going to be giving away adapters with refrigerant and tanks as well. I think Johnstone's got a national promotion, right, Eric, that they're giving away an A2L adapter with every jug of 32 or 454B. I just saw it yesterday. Yeah,
that's entirely possible. I only do training here. I don't deal with that
yeah,
side of it.
yeah. I think that's yeah. I saw an advert for it yesterday. So
okay.
Yeah. So right. So the thread adapters we talked about. Any hand tools. You probably want to make sure that they're non-sparking. Brushless DC motors. Vacuum pumps we spoke about. Try and go for a spark-free design, something that is A2L compatible. I'll run you through a couple of slides of some of the products that JB has, but we do have a newly designed A2L pump, which has a brushless DC motor. And we also have an AC motor pump, which is an actual spark-proof design. So that means it's got a sealed capacitive unit, and it's actually rated to A3, and that's been through UL testing as well. So that's used in higher volatility applications. Again, we come back to what I was saying earlier on. There shouldn't be refrigerant in the system anyway, but you could have a buildup of flammable refrigerants in an enclosed space, and in that case, you'd actually be wanting to use a proper spark-free pump. Leak detectors must be able to detect HFC and HFO blends, and the majority of them out there already do. So I don't think there's going to be much change in leak detection. If you've got one that already detects those refrigerants, you should be fine. Recovery machines, again, spark-free design. That is the one area that I would potentially look for some sort of a certification or testing to UL, as I mentioned earlier, because you are actually touching the refrigerant. And lastly, the recovery cylinders. And I mean, do you think I've missed anything out there, Eric? I think that's a pretty comprehensive list. I can't really see anything else from a tool perspective.
No, I think you got it. One thing I did want to point out, though, because just put emphasis on, if you notice on the vacuum pump and the recovery machines, he's got on there, and I know this to be accurate, right? They want a minimum of 10-foot cord.
Yep.
So so we've got some equipment out there. So even if you are using something that's is old reliable to you, if it doesn't have that 10-foot cord, and if it does get unplugged, we just want to do everything we can to prevent a spark, because strange things happen sometimes, and anybody who's been out in the field, they know that sometimes you get just the oddest thing happen. You're working on one unit and there's another unit next to you that's leaking and you don't even notice it, right? We don't want to create a spark. So
absolutely,
it's always best to just let's get in line with what we need to do. We're all professionals, and we should be acting as so and be properly equipped to do the job.
100%. All right, just a brief slide on what system components change, and we briefly touched on this earlier on. So your compressor changes in the new equipment. Very different compressors. You can see the onboard protection, variable frequency drives, and the relays are all sealed. Again, trying to protect against any sparks being produced. Expansion valves are changing because the characteristics of the refrigerant are different. The charge changes, slightly smaller, as I mentioned earlier on, 32 and 454B. I think 32 is a little smaller charge again than 454B itself, about 10% smaller. The refrigerant detection system, so any system that's got a charge greater than 4 pounds will require an RDS, which is really a sniffer mechanism, really just checking for the presence of refrigerant. And that's going to be a bit of a change for most techs because they won't have seen that before. And no change on the refrigerant oil, which is a relief. So it's still a POE. Yeah, no problems there. So if you're used to 410A today and you move into 454B, I don't think there's going to be much in it apart from the RDS. Would be fine. It's maybe a bold statement from somebody who doesn't install equipment, but that's reading everything. I think that's pretty much a fact.
Yeah, a lot of the changes outside of the tooling are going to be revolved around just, your site evaluation, right? There's some other safety concerns that we want to look at when we're before we start doing the work or changing a system out. So,
Yeah, and I've
um,
summarized those right at the end. I've got a bit of a
oh, okay.
couple of summary slides on best practices. So yeah, it's
All right.
evaluation,
Good.
ventilation, all the rest of it, right? So absolutely.
Sounds good.
All right, so I'll just go into a little bit on the tools. So, and we've touched on this the whole way through. So, recovery machines, obviously we're using it to remove the refrigerant from a system. The A2L specific requirements. Brushless DC motor or spark-proof motor design. And again, I would recommend that you look for something that has been properly tested rather than self-certified by the manufacturer. The 10-foot locking IEC cord that we spoke about. One of the requirements that I've put here is a purge capability, right? And there's going to be a big push for the reclamation of 410A. As that phase down continues and production, there's less production of 410A, and you really want a recovery machine that you can purge to avoid that cross contamination of the refrigerants. Some of the older ones out there, some of the more popular ones out there, they might be yellow in color even. They don't have a purge function, and that could be a problem moving forward. So if you are you're in the market for a new recovery machine, look for that purge functionality. And I put optional here, auto shut off. I mean, it's always great. I mean, the industry leading machine out there doesn't have an auto shut off, so you've got to be with that machine the whole time. Most of the newer ones out there at the moment will recover the refrigerant and then they'll switch off automatically, so you don't have to be on the job site. So just something to look for when you're looking for a recovery machine. Vacuum pumps, spoke about that, same thing, right? Brushless DC motor design, that 10-foot cord. I've got optional here, a blank off valve, and optional gas ballast. Those are like high-end features on vacuum pumps. But it's, again, if you're looking for a new vacuum pump, those are two very useful features to have on it when you are evacuating, particularly because they're calling for a triple evacuation for A2L systems. So there's a lot more work involved in evacuating a system. I'll touch on that a little bit later. Gauges and manifolds, new PT charts for the gauges, similar pressures, but there are new PT charts. I mentioned earlier on about checking that your digital manifolds do have the PT charts for the new refrigerants in them as well. There are people out there actually saying that potentially separate gauges and manifolds and hoses for each refrigerant, again for that cross contamination issue. I don't know so much about the gauges themselves. Hoses potentially yes, but I think you could probably I think you're probably okay with a 410A 32454B combination, and that's one of the combinations that we have out there at the moment as well. And finally, leak detectors. So, most of them are sniffer types out there. The heated diode ones, but, a little bit of care because you've got a heated diode, and obviously that's a heat source. But that, when we look at how much heat is actually required to actually ignite an A2L, I mean that's not really going to be an issue. But refer to the manufacturer and check that that they've certified it for A2L. And obviously they need to be able to detect the HFO blend. So I've got a couple of slides here which are JB specific, and I didn't want this to be a sales session for JB, but again that's what I know. So I've gone through and just really shown you what's available at Johnstone Supply, because Johnstone Supply stocks pretty much everything that JB does. We do have a whole range of A2L vacuum pumps and the spark-proof pump that I spoke about, which is on the right-hand side of this slide. And I've just got a couple here in detail. So we have a 12 CFM We call it the Platinum Beast. That's a 1 horsepower brushless DC motor. It's got a 10-foot cord. Sorry, I lost that. And that's A2L compatible, 2-year warranty. We have a battery powered pump, the Platinum Flex. That's also A2L compatible. Same thing, brushless DC motor. Our particular unit takes a JB battery. Sorry, I don't know what's happening here to my slides. There we go. It takes a JB battery, but it also takes a Milwaukee and a DeWalt battery with a little hack that you can do on the top, which I know you're recording this, Eric, so and James, but maybe you can just take that bit out afterwards. We have the Platinum Pro, which are our new range, which is designed specifically for A2L. So it was designed from scratch with a brushless DC motor. It's got a brand new oil management system, big backlit sight glass. The oil fill system's great. You take a little cap off the top, and it's got a spike underneath, so you can take a full quart of oil, pierce it onto that spike, give it a squeeze, and it fills that pump up automatically to exactly the right spot. Nice big quarter turn ball valve on the front to actually drain the oil. You can drain it in basically 30 seconds. Really quick to do. And most importantly, it takes a full quart of oil, which means it's less time between oil changes as well. Just as a matter of interest, the 10 CFM one is featured in the Johnstone July Flyer, and we have a JB July giveaway promo as well, which I'll just mention at the end of this, which many of these pumps are actually featured in. Right, recovery and adapters. So the F6 Boost, which I spoke about earlier on, A2L and A3 rated, so you can recover, not that you want to recover propane because you can vent it, but it is capable of doing highly flammable gases. Sorry, this is irritating. But you see, we've tested it to the ISA standard, 1201-2216. So, and that's really the ignition-proof standard. So this is an ignition-proof recovery machine. Your A2L adapters, we do a 45-degree version and a straight version for the cylinders. You've got the gauges as well. We've got the 32, 454B and 410A, 3 1/8 inch gauges, and they're backward compatible with all our manifolds. So any JB manifold, if you own one, you can take your old gauges off and put the new gauges on. And finally, we've got leak detection, and so our LD5000 Prowler, it's an electrochemical leak detector, detects all those HFC, HFO, and HCFC blended refrigerants. 10-year sensor life, and it's actually got a vibrating handle, so you can use it in noisy environments with it, or quiet environments where you actually don't want the alarm to go off. That's one of our top sellers, also available at Johnstone. All right, so that's just a brief snapshot of the tools, and I'll just go to the slides are jumping all over the place here. So a little bit on the best practices. So recovery, we mentioned earlier on, you can't vent A2Ls. You must recover using a rated recovery machine. And they've got to be recovered as per whatever regulation that you have in your particular states. Obviously, no mixing of refrigerant. Make sure that your recovery machine's got a purge function to prevent that cross-contamination. You have to recover into the new DOT-approved left-hand thread cylinders marked with the red stripe. And, the recommendation is not to go above 80% on the fill because of potential build-up of pressure inside that cylinder. There's new labeling requirements as well, which I have not got into in this presentation. That's something you're going to have to find out for yourself. But there are new labeling requirements for A2L, and they're a lot more onerous than they were for 410A. I don't know if you've got any information on that, Eric, at all. Is it something that you guys talk about?
Yeah, primarily what we've got is, of course, the new equipment will actually have the little flammability stickers or labeling on them, indicating that they do contain a substance that is classified as flammable, even though it's just barely flammable. And then there will also be a new UL listed label that is going to be required to be filled out by installing and servicing technicians.
Right. And there's something about having to record the charge every time, and that's the total charge of the system, right?
Yeah, that's
On the
that UL. That's that UL listed label that
Yep.
I'm referring to. Yeah,
Right.
you actually have to record your evacuation level, your nitrogen pressure level, all that has to be recorded, and it's not deemed optional. It's these are all new
It's
requirements.
mandatory. Yeah,
Yes.
absolutely. All right, so evacuation and charging. So I mentioned triple evacuation now required for A2L systems, right? So, purge your line sets with nitrogen, and you want to be evacuating that system with that A2L rated pump 3 times, basically, starting at 2,500 microns, and then repressurizing with nitrogen, and down to 1,500 and repressurizing, and then down to under 500 or whatever the manufacturer's specification is for that particular piece of equipment, and then performing your rise test at the end of it. So, a lot of people are doing it once now. 3 times is there's a lot more work required, and this this if you're a tech out there who is using a 1/4-inch hose and you're not putting your Schrader cores, now's the time to move to a bigger hose and pull a Schrader core through a valve core removal tool, because it's going to save you a ton of time when you're doing all these multiple evacuations to get your system ready for charging.
Yeah, just real quick on that, Tom. Just for folks who don't know, a 1/4-inch hose will only do about 1 CFM. So if you're running a 6 or 7 CFM pump on 1/4-inch hoses, you've got way more pump than you need. And I just real quick wanted to point out up on the top, it talks about, or you have a slide in there, or a bullet point, sorry, that talks about the free flow of nitrogen when brazing, or what we call purging with nitrogen while brazing. That is also a new requirement if it's going to contain an A2L. You must do that if you're going to be charging an A2L refrigerant into the systems.
So nitrogen sales are going to go up massively.
Oh, yeah.
Yeah. All right, and look, we always want to use a micron gauge when determining the vacuum, the vacuum level in a system. I mean, you want to really try and avoid something that's built into either a manifold or trying to use your gauges to determine vacuum. It's impossible to do so. Anybody who thinks they can determine vacuum by using an analog gauge is kidding themselves. It's an impossibility. You can't do it. There's just in that tiny 30 inches or 3 inches of mercury that you've got at the bottom, you can't determine whether you're at 500 microns or not. So you really want to have your vacuum gauge right at your system port on the side of a valve core removal tool, and that's where you measure the vacuum level of your system, as far away from the pump as possible. It's amazing how many people are not doing that, but that is the best practice, and that is what any manufacturer out there will tell you, even the ones who build their micron gauges inside their manifold.
Yeah, 29.9 inches of mercury is 500 microns.
Yeah.
29.75 inches of mercury is 4,000 microns.
There you go.
That's less than the width of the needle on most analog gauges. So yeah, they're just 2 different scales. You can't, we don't. It's like we need to measure in inches, not yards.
Absolutely. All right, and that's pretty much it from my side. I think we may have lost a couple of slides in best practices because of my slide pack going back and forward, because there was one around evaluating the room and making sure it's well ventilated, etc. But these are all pretty much standard guidelines that you can get in any one of these resources that I put out here. There's a lot of training available out there. Johnstone are doing a lot of training. I mean, I know you guys are incredibly, the Rhino group are incredibly focused on training. So, if the guys want to know more about some of the best practices around this, I'm sure that there'll be plenty of opportunities to actually learn about that with yourselves, Eric.
Yeah, we do A2L training that will include ESCO safe handling certification test. And it's very informative. Like I said, I ran that in Salinas yesterday for 20, I think I had 23 people in that class. It's not major changes, but there's enough changes that if you're not up to speed, please get some training. Don't risk yourself, don't risk your customers. Know what we're dealing with, understand the small differences that we are dealing with, and come see us.
Right, any questions from anybody? I don't know if you can open up the mics. I mean, if anybody's got any questions.
If you do, the floor's open. Please feel free. Jump in.
It's always good if there's none. Means we did our
Yeah.
job.
Yeah, that means the job was done, right?
Well, I do want to thank you again, Tom. I appreciate it. And we will be continuing on these. If you are in this and want to review something later, or want one of your buddies or your boss or somebody to see it, don't stress. We will have this recorded and put up on our YouTube channel. You can find that at powerofjsog.com/training-center. And again, thank you very much, Tom. I appreciate it, and we will talk to everybody soon.
All right, pleasure.
All right,
Thanks,
thank you,
guys.
Tom. We appreciate it.
Have a good day. Bye-bye.